Hello everybody, hopefully you are seeing a screen right here. This is John Beverley, and you are looking at the first lecture, hopefully a clean one, for Ontology Tradecraft. And so excuse me, just had something to eat. What I want to show you is kind of my workflow, which is I largely use Visual Studio Code when I'm trying to work in the actual ontology engineering space. I'm going to show you why. I'm going to encourage you to use it too, because I think it's going to simplify a lot of your workflow, and also it'll kind of provide us an anchor for what to work on. And so I'm using a Mac. All I have to do is type in Visual Studio Code and it'll pop up over here. Looks like I got some updates. I'll do that later. What I want to show you is how it can handle version control, which is pretty important, one of the main reasons why I use it. Now, if you're participating in the class, then no doubt you know that you come to this GitHub page here. This is an organization, which is essentially an organization in GitHub is essentially a bunch of repositories all grouped together under a common heading. And so this is the Applied Ontology in-core education organization. You see it's got its github.com Applied Ontology Education there. That's easy to find. Bunch of courses here. Some of you have seen these before. Some may be new to you. Like, for example, there is a tutorial session that I gave over the summer, which some of you might not have seen. But in any event, for this Ontology Tradecraft, you click here. This is the class. You'll find all the course material for the Ontology Tradecraft course here. You'll see I'll be posting this video here under that heading. It'll be this link will take you to YouTube, and I'm going to record videos here as well. Here you'll also see our meeting time, which is on Mondays, and then a Zoom link for attendees who are not able to make it. We have some extra content, and then descriptions of the repository. So this whole thing is called a repository, this page. It is part of GitHub. As you see, GitHub is a cloud server space that runs the Git protocols. Git is a kind of a strategy for version control, tracking changes, updating changes, making sure that whatever kind of file change or update you make, using its standards, you can always undo, you can always revise, you can always go back and check. It's just a clear record of every single change that's ever made. GitHub, as I said, is a cloud server plus a UI, a user interface that allows you to interact or use Git pretty easily in your browser. But you can also see some of that kind of version control feature just by clicking around. And so if you'll note, like, what this is, what I've just clicked on here is a commit. This is the most recent change to this repository. It was 3 days ago. You can see the things that are changed, the things that were removed, the things that were added. You can click around. Some things were just completely added, so I added this turtle file, added this turtle file. And what I mean by added, you can go back through the history and see, from previous commits, what it looked like before. So what you'll see here, I was just looking at that commit 3 days ago, which had that stuff about adding turtle files. If you click on this commit here, you'll see I've just changed this is an IPYNB, that's a Jupyter notebook extension, and I just changed some things in the file associated with that. You can see where that file is located in this repository, so it's under projects, project 1 assignment notebook, and then here's the name of the file itself. This isn't expanded, but you can kind of see it implicit there, the hierarchical structure. And then you can keep going on. Like, you can see, you can basically track the changes, any change that's happened in this repository, all the way down to the very first one, the initial commit where I just put the license in. And the second one was probably more informative, where I updated the README. The README, incidentally, is that kind of the landing page, the first thing you come to, where all that information was, right here. The README. You can see I made this initial commit. It looks a little different than what you see now. I had like readings there. I've changed my tune about some of that. And indeed, you can, as you move through the commits, if you're interested in what happened, what changed, you can kind of look through, and the red indicates where I've removed something, green indicates where I've added something. And that's essentially, good way, again, just highlighting here the version control aspect of GitHub and how you can kind of track that, trace it. Now you'll see file structures here. Now I some directories, things you can explore, test cases, etc. I'm sure you found the project pages, kind of easy to navigate. Now I'm showing you this not because I particularly want you to work through the GitHub server so much, but because I want you to pull it down into Visual Studio Code or pull it down to your local device. And so I usually work in VS Code, and the way I get all of this information over to this application which sits on my computer is I clone it. And so there's this little button, code. You can find you can copy a URL here, and you can clone all of the information you were just looking at from that GitHub server to Visual Studio Code. So if you download VS Code, I definitely encourage you to do so. You can do it here at code.visualstudiocode.com download. You can find a Windows version, Linux, you can find a Mac version. If you do that, but copy that URL, you can come over here to VS Code if you have it on your device, and you see up here at the top, at least for Mac, you can pop open a terminal. Now, and what you're going to see is, so I have like let me see if I can, okay, sorry, I was just removing this, yeah, don't worry about that. So I had a platform running, or I had something running in the background, which is why you see base, but you will probably see something that looks, in your terminal, it looks something like your name, the name of your computer, and then squiggly line, and then this symbol here. So this is essentially the kind of root of your computer. You can look around to see what's in your computer. One way to do this is if you're in a terminal on a Mac, you can put list, and list ls is list all the files that you're going to see in that root directory, right, or that root file structure. And so what you're looking at here, under here, all this stuff. This is all this stuff in John's computer, right here. Now, I've got nothing to hide. What I'm going to do is I'm going to pop over here. I'm going to click on John, and you're going to be able to see some similar content, right? So all CCO YED diagram files. Look at that. Boom, right there. You got applications right there. Some of these are folders, so some of these I can move into. Some of these are files, like BFO core. These are just files on my computer. Now, one of the interesting things, if you're unfamiliar with the terminal, is that you can move through the terminal, move through the directory structure, using commands, much like you would just move through these structures just clicking, right? Click, move here, open that file, folder, go back, It's easy peasy. The way you would do this is this cd command. It's like change directory. I want to change directory, and then you have to you type in where you want to go. Now, you got to be careful because when you're talking about moving into some directory or moving into some file, you got to make sure you're moving into an actual file. So watch this. I'm going to try to move into a folder. I'm sorry, a file, not a folder. Not a directory, but an actual file. I'm not going to be able to do it. So I'm saying change directory into something that's not a directory. Boom. That doesn't exist. Okay, learned my lesson. The reason I'm walking through this is because I have a place in this directory called repos. It's a folder, repos, and I want to change my directory into repos. Okay, I've moved into repos. I'm just going to list off what's in there. And so the stuff that's in here, Calore, Common Core, Logic for Ontologists Seminar, In-Core Network, all of these are repositories that I have on GitHub. And so repos is where I put all of my repositories. It's a folder I have on my hard drive. It's got all of my repositories, the local copies of repositories. So this is where I put them. Now the reason I moved over here is because I want to clone the Ontology Tradecraft repository into this repos folder. Now I gotta be careful. I'm gonna move to that folder so that I can clone and copy all this information into this folder. Because wherever I am, I'm gonna clone it there. Now there are other ways you can add like other commands. You can say clone it, but do it over here. Just straightforward, easy way, just to highlight this for you. You can just move into the directory and then clone it directly there. And you do it just like this, git clone, and I'm just going to copy or I'm just going to paste that URL I got from here, right? That one, just to remind you, code right there, just copied it. Just going to get, the git command that's telling Git, hey, get ready, I want you to do something for me. And then git, I want you to clone this repository right here. Now you're probably thinking, John, don't you already have this repository in your local drive? I do, actually. I did, but right before this video I deleted it so that you wouldn't see it here. And then I said, all right, I'm going to clone it again. I'm going to delete it just so you know how to do it. And so if I list one more time, you should see it in here because I just cloned it right there. And if you look up here previously, you're not going to see it. All right? It's a simple count, right? 2 open slots remaining there, 3 slots open remaining there. So now, what I can do is I can move into that directory, Ontology Tradecraft. And now I'm in the directory. I'm in our class page, documentation, license, projects, readme. Look at that, documentation, projects, license, readme. All right, there's going to be a mirror here. Now this is how you can straightforwardly clone a repository into your local place. I'm going to close this now because I don't want to play around with the terminal that much. What I want to do is I want to open this. So I'm going to navigate here, just file, open, go to repos, and you'll see it at the top if you have it, changed to date modified. I'm going to open this in Visual Studio Code. Now, get rid of that, get rid of all this nonsense. I don't know what, not interested in using this. Go away. How do you make this go away? Alright, now you'll see, should look pretty familiar. GitHub, documentation, projects, license, readme. Now I can click on this stuff. I can say, for example, click on the readme, and what it does is it shows me the readme in Markdown. So you'll see it here rendered, in a nice pleasing way with links that don't work. You'll see here in Markdown, this is Markdown being a syntax that GitHub can read to generate this sort of page. You'll see why there's these links here don't go anywhere. Why, if you click there, it just takes you right back to this page. That's the default behavior for when there's no HTTP link right there. So course introduction and tooling setup, I haven't yet put the video up for this, and so I haven't yet put the link there. Now you can see there's again a direct relationship between what you're seeing here in Markdown and what you're seeing here on the README. Okay, so I'm going to pop over here to project 1. Now project 1, in this project, if you go over the README, I basically outlined what I wanted you to do. And so what I wanted you to do was confirm that your Python environment is ready with required packages, and then practice a little bit building RDF, Resource Description Framework data, using a Python package called rdflib. And I also wanted you to get a little feel for GitHub workflows, so cloning, committing, pushing, and tests, and then understand how autograding will work for the future for more complicated projects. Now we just did a little cloning here. In fact, I gave you the what to do here. Clone this repository. Now I've walked you through a little bit what that looks like on my end. Now in your local repository, you can create a new Jupyter notebook in Notebooks, and you can call it this, right? Where you do the following, and this is part of the project. Now, as you see, I've already got one here, right? I already did this. Now, when I say, when you're one of the benefits of using Jupyter Notebook one of the benefits of using VS Code is that you can find plugins, and I've got a few. One of them is Jupyter. I also have a few others. I have GitGraft, it helps me look at GitHub. I have GitHub Actions, GitHub Copilot, Gitignore, GitLens. Some of these I use more than others, but there are quite a few helpful plugins that will allow you to render different syntaxes, to lint them, that is to say, like check syntax for different programming languages or whatnot, but and just like help you with your development background in general. Jupyter is a really useful plugin to have. I strongly encourage you to use it because it makes kind of the development process for working with Jupyter Notebooks very easy. Namely, to create a new Jupyter notebook in Notebooks, all I had to do was create a file with this file extension on it. I'm going to show you, so I already have one there. I'm going to show you how you can do it again. So I'm going to just open, I just right clicked here, I'm going to say new file, I'm going to put test, and I just put that file extension, and now look what happens. Okay, I have just put a test in here, and I just gave it that file extension, and that Jupyter plugin knows to read this file as a notebook. I can generate things. I can code in this notebook. I can get rid of stuff. Right? And let me show you. So I can, for example, and I did this here, I can open a code block, drop this in, and then I can run it. Run. Now when I run, I'm going to need to have some Python environment set up because this is Python. What I've just dropped in here, and I got a little bit ahead of myself on purpose. So while this is a nice notebook I can play with and run code in the blocks for, I can't actually do anything with it yet. I can't run it because I still need to make sure that the code I've written in has the kind of like setup on my computer to be run. And so I know, as a matter of fact, I already have Python on my computer. Now you should go download Python. You can find it in many places. There's a link in the the documentation as well for this class. You can find some links to find where to download any like needed packages. So you should check that out. But I'm going to assume that you have downloaded Python. Now what you're going to do then is when you go to run, you're going to be asked the following question. You're going to need to pick an environment to run it in. This is a Python environment that you'll be running it in here. Depending on what you have, you'll probably have one or more different packages. I'm going to pick this base one. All right, well, whatever, run it anyway. And it's going to run this code, and it's going to return this result. Now, what's going on here? Okay, if you're unfamiliar with coding, don't worry. You're not going to have to do too much of it. You're going to have to do some. But I've imported a Python package here called rdflib. rdflib is very useful. See it just looking at the wiki page. It's a Python library for working with RDF, Resource Description Framework. It's a very simple language. You can use it. It's used widely, used in many different projects, and it's essentially a way to engage with graph structures. So like using Python. Python's a very easy language to play with. We're going to be playing with it a lot, so it's crucial that you get accustomed to using it. We'll be writing Sparkle queries. We'll be using Shackle with it. And so what I'm doing here is I'm telling the code, I'm telling the block here, like, listen, before you run it, import rdflib. I also have it importing Sparkle wrapper. So Sparkle wrapper is a way that I can it's something we will learn to use in subsequent lectures, but it's a way to encode Sparkle in Python. So you can, if you're familiar with Sparkle, it's essentially allows you to call queries that should look familiar. So here's a Sparkle query. Now Sparkle query, if you're unfamiliar, don't worry, I'm going to have a lecture on this. A Sparkle query is it's an information extraction strategy or language, Sparkle, that will allow you to question or ask questions against a graph structure and pull back matches to your questions. And so so basically I won't go into the detail here, but it's essentially saying here's a structure that I want, here's some graphical structure that I want to know if this or that database has a match to, and then you kind of pitch it against the database and it will return anything that satisfies that query. Now Sparkle wrapper is a way to wrap queries like that within Python and use them in other libraries or with other Python code. And so we're going to be doing that because I don't really want you to go around like writing a bunch of Sparkle. I want you to wrap it if you're going to use it at all, because it's going to be, or we're going to wrap it because we're going to be using it with code. PyShackle is a way to validate like RDF graphs using this standard called Shackle. And Shackle is something of a schema language. So where Sparkle is information extraction, Shackle is does your graph have the right shape? There's a Python way or Pythonic way of using Shackle. We're going to be using PyShackle later for the same reason we're going to be using Sparkle wrapper, because we're going to be generating scripts that kind of leverage these semantic web tools in larger programs. And so we're going to need to be able to query graphs, and we're going to need to be able to validate graphs. So for this point, for this project, I'm basically just asking you to make sure you have your environment set up. So I want you to import these, and then I want you to print on your computer what version you have, right? And then I want you to, for rdflib, for Sparkle wrapper, and then there's a try feature. So if you got it, print this off, installed. If not, error. And so basically this is kind of an attempt, a try. If you don't have PyShackle, I'm going to try to import it. I'm going to see if you have a version, see if it's installed. If not, throw an error. But in any event, if you've got the suite on your computer, if you've got rdflib in some version, if you've got Sparkle wrapper in some version, if you've got PyShackle in some version, this is what you're going to get as the output when you run this code. All right, so back to the README, because I had said I want you to clone, and I want you to print your Python version. I want you to import this in that Jupyter notebook. And then, but there was one other task I wanted you to do. I wanted you to parse a file called sample TTL, TTL being the file extension for Turtle, and then print the number of triples that it contains. And then I wanted you to commit and push, and I'll talk about that in a second. So I did provide you with sample right here. It was a simple, very simple one. Now this is in Turtle syntax, so the terse triple language, and in Turtle, because it's based on RDF, it's a serialization of RDF. That is a syntactic flavor of RDF. Essentially, you're going to see triple structure. You're going to see subject, predicate, object. Now these little abbreviations, you can see them at the top. EX colon is just because I don't want to write this out. But technically, if I replaced EX, EX colon with this URL or the snippet here, the full subject would look something like this. So it'd be just like that. That would be the subject. RDF type I'd have here. If I got rid of these prefixes, that is, it would look like this. And then, of course, the course would, I'm just going to copy that and replace schools. Boom, and then get rid. Let's see. This first line here is equivalent to this line 7 here. Basically, I've just pulled out the abbreviations, added that snippet to the front, and these are unique IRIs, right? They're meant to be globally unique IRIs for each of these terms. So, you know, AO634, RDF type, RDF being like a vocabulary for the resource description framework. Type is a part of the reserved vocabulary for that. And then course, I just made up AO634 and then course for this. So that's one triple. And then I've also here has another AO634 title. It's got a title, Ontology Tradecraft. Essentially, I'm saying, here's a file. I've got some abbreviations to simplify it for triples, and I've got two triples that I want you to think about. One saying AO634 Applied Ontology 634, which is the course, is a course, and it's titled Ontology Tradecraft. Now, that's the file. What did I want you to do? I wanted you to parse the provided sample turtle file and print the number of triples it contains. Now how did I do that? Well, I had actually done this for you, and so here's how it did. So I wanted you to, I had this little script. I was assuming some of you would look through and see what the tests look like. It's always a good idea to see if you're going to pass or not, to see what the test is. And what this little code snippet does, as you see, it's right below this one that I was already showing you. What I've done is I've imported from this path library, which is a file system. It's like methods to call in path objects, basically a way to like identify where kind of things are living on your hard drive. And it also imported rdflib here before moving into identifying a list of candidate paths. And so this is essentially saying, look, I'm going to run some code that looks in different project places, because, you know, some students end up moving things around some places, and I just wanted you to see some examples of like candidate paths. If you wanted to put something here, there. I did say I was trying to be specific about where you put your projects, but it's okay. I didn't want you to get points off or not pass just because you had the wrong path. In any event, the more interesting part is I've defined this little variable here, and what it does is for some path in this list, if it exists, then what I want you to, if it doesn't exist, that is, then I want you to return, try again, got the wrong path. Okay? Now, otherwise, the real interesting part is if you find it, you've like locked onto some turtle file and it's got the right path, then here's where the rdflib comes in. So you define here a graph. You give it a name, like G, and you're initializing the creation of a graph. Here's this graph, and what you're going to do is you're going to essentially parse against that graph that you created. You're going to say, parse that graph using this path here from these candidates. Ultimately, if you've done this correctly, and it's, you know, if you're looking for through the right path and you found a turtle file, that's what that formatting's saying, then what you're going to get is a parsing that goes on for that file right there, which is to say a checking to see if the file is valid RDF or valid turtle, more specifically. And so rdflib has some built-in checkers for that. It's parsing. Just want to see, hey, does this actually pass muster? Is this good? Does this work? And then if it does pass this, there's going to be an evaluation that goes on of the length of that file, and it's going to measure, not starting here, so it's not going to say they're like 5, the length is 5. What it's counting are the number of triples. And so this is the straightforward way, where did I put that, of determining the count of triples, the number of triples there are, is just returning the length of the graph. And so that is essentially it. And so to pass this, what you had to do is, again, clone the starter repository. And then your local repository, create a notebook right there where you print the Python version, import these bad boys, and then parse using rdflib, the sample turtle file I gave you, and then print the number of triples it contains. Okay? And then, so your answer should be 2. Now, you're supposed to then commit and push your notebook and any code changes to GitHub. So, I actually made a change to this repository right here. Now, I don't want to keep this because this was just me playing around, so I'm going to remove that. I'm not going to save it, but I do want you to see. I'm going to go ahead and delete this actually because I don't want to put it on my repository. Move to trash. Now, what I'm going to do then is I'm going to go over here to sample, and I'm going to make a slight change. In fact, I'm going to do this. I'm going to bring that. I'm going to replace EX in every place. You know what though? I don't want to do this by hand. There's like 2, 3. Who has the time? And so what I'm going to do is I'm going to look for EX colon, and then I'm going to replace EX colon with that. Now I don't want to close it off, right? Because if you're paying attention, I'm supposed to put an arrow around. But I do want to replace all this EX colons with this. I'm gonna click this little button, this little replace all button, and boom. Haha. Now I still gotta do something. I gotta go, okay. I gotta close off, close off, close off. Now, as I said, these are syntactically equivalent, or these are semantically equivalent. They'll get rendered the same way. I gotta be careful though. It looks like I got an extra one right there. EX. You gotta be careful with that find and replace. Now, but this should be equivalent to what I had before because I just removed the abbreviations. In fact, I should be able to just remove that abbreviation, and I should still get the same count. Now I'm gonna save. You can do this in a couple of ways. You can just say save up here, or you can on your computer just get. I think for a Mac it's Command and S. Boom, save. Now now something's changed, right? Look over here. I've got a 1. I've got this. It's now, brownish. I'm going to click here, and you'll see in source control, I've got changes that have been made. Sample turtle. Now, I've modified that file. Now, so far I've only modified it on my local computer. I want to push it back over to the repository, right? I want to push it back over here because right now I've not done anything. If you just for this, as far as this project is concerned, or this page is concerned, if I look here, I'll check it out. Just gonna go over to source. Oops, that's not the right one. Gonna go. Where did I put that? It's in projects, notebooks. Should be in notebooks, right? Right there. If you'll look. What do you see? Let's compare and contrast. The server, that cloud server on GitHub, has not been changed, right? I've just saved it on my computer, but nothing over here has changed. Okay, so now I want to come back here in this little source control button. I want to push this over here, push my change to the repository. So I'm going to do that. I'm going to commit, which is to say save it, in like a staging ground. Like on my local device. It's kind of like a preliminary. I'm about to push this, and I'm going to push over. Now I got to put a message in, test for video, and I'm going to save that. Now it's not going to push until I close this, and I always have to put a message in. So I'm going to close that, and then here's what's going to happen. Like over here, you'll see a GitHub action is going on. It's checking to see that I didn't do anything crazy. You're actually going to see a little X here when it's done. That's for different reasons, but I'm going to ignore that for a second. But what's going to happen is if you come back over here, once this little button has passed, now you'll see that I've actually just changed the local file on that server, or the file on the server, to match this. and now I've made a commit on my local place and I pushed it over. Now you're going to see something a little different because you're going to be creating a branch. You're going to be creating a copy on your GitHub, and you're going to be pushing things to your local, like you're going to be pushing things from your local computer to your GitHub repository. I can actually see when you're doing stuff like this because I can see forks. So forks are like, forks are copies over on your GitHub server. You can see this is Austin. I'm just going to pick on him for just a second. But you'll see he's copied everything over, right? And you're probably going to see some of this too on yours. So this is Austin's, not mine. A lot of it's going to be in common. And you'll see here this branch, his branch, like his copy, is 1 commit ahead of mine and 12 commits behind. That means my main branch has made 12 changes that he doesn't have on his. And let's see what these are. So I added YAML, I updated some paths, I added some PyTests, I was debugging, I got bored and started giving it funny names. So these are changes that I have. Now he could update his. In fact, I could go in, I could come over here and click that button and just say, hey, I'm going to create a pull request. I'm going to make a request that you update. If I click this button, he would get an alert and say, hey man, and we could talk about it. We'd discuss and review to see if he wanted to. And if I'd be asking, if by doing that, I'd be saying, hey, can you make all these changes to your repository so it's up to date? I'm not going to do that. I'm going to look over here at his 1 commit ahead because this is a change that he's made to his repository that I don't know about. So he's changed something too. Let's see what he's changed. He made some changes to that Jupyter file, and he's added a whole bunch of stuff. He's removed some stuff, right? So he made some edits. Now he could create a pull request, and what that would mean, you got to keep this straight. Because this is him ahead of, like his change is ahead of my chain or my branch, my repository. If he were to click this create a pull request, it essentially he'd be saying to me, hey, can I make a change on your main branch? And so creating a pull request, when you're ahead of mine, when you've done your work, you create a pull request, I get an alert that says, hey, you want me to look at something, right? So I'm going to go back over here to the code. Now I've made my way back, and I'll show you pull requests. There's some open ones, there's some closed ones. So the closed ones, I've closed the ones that are either like outdated or the ones that just passed. So one recently was passed. That red's not a bad thing. You see here there was a run. This individual submitted their work. The test that I have set up ran against it, and it passed. And so I went ahead and closed that. There are some other submissions that are open, but this is basically where I will see them, either closed or open. You see Austin, of course. He sent just a little bit ago. It looks like he sent his over, his project 1, and it got a check mark. You can even dig in and look to see what passed. So here, this was his work that passed the tests that I had. And what were the tests that I had? Great question. So when you make a pull request, when you've got a commit ahead, you made some changes, you push it over to me. What I do is I click a little button because I've got some files here I won't go into right now. I click a little button that says run a workflow. And you can see what I run exactly in this little folder in this file called test environment. And this is exactly what I test you for. And this will check to see if your work is good. I import some things, blah blah blah, do some file paths, blah blah blah. Then I define some functions and I run them against them. Essentially what I'm saying is I want this script to check that you have the right triple count, namely 2, and that you have a version of Python that is at least version 3. Now, that is what I'm strictly speaking testing you for in this project, in project 1. So I did want you to import rdflib and sparkle wrapper and all that good stuff, but I also wanted you to print your Python version and then get the right number count on sample. Now, if you've done those two things, really, you're going to be auto-graded and you'll pass. You do the checks, and then essentially, you pass this. Now, the rest of the README here have a little description about the grading, have a description of the files in the repository. Hopefully this matches up with what you're seeing. There's a test folder, the source folder, and so on. But ultimately, again, just want to reiterate kind of a high-level workflow. This project 1 was meant to bring you up to speed on getting your environment set up, teaching you a little bit about sometimes about the terminal. Really, I'd like for you to be using VS Code because it just makes things simpler, and if something's not simple, then go look for a plugin to make it simple. They're easy to find, it's well supported, as well as getting comfortable and accustomed to using Git and GitHub. And so hopefully you are. It seems like several of you are. Hopefully you've gotten your Python environment set up and you're ready to rock and roll with rdflib and some of the other stuff. Hold your horses, because in project 2, which you can see right here, I actually have you do some of that old school modeling that we know and love, but all in the interest of having you feel the pain. Now, I know a couple of you struggled with that, but setting up this environment that we've done today in this first project is all in the interest of getting you ready to be sick of doing things this old school way, and then ready to jump in and start automating as much as we can, do some ontology engineering in the new school way. So with that, we'll close and get ready for the next video.